Welcome to week 11 of SO Remediation. Today we are talking about transformations. A couple of quick bits of vocabulary. You're going to see these words used a lot. The pre-image and the image. Just remember, pre means before. This is your picture before anything has been done to it. Before. This is whatever shape or a picture or a line or dot that you start with before you move it. The image is going to be your after. So if you ever hear something just talking about the image, something has already happened to it. If you see the pre-image, nothing has happened yet, but something, some sort of transformation is going to occur. And a map are the rules on how something is being transformed. You could map something, maybe it's a reflection over the x-axis. That would be a map for a reflection. For a rotation, it would be about a point, meaning like the origin, and it would tell you some number of degrees, so maybe like 90-degree rotation about a point. That's a rotational map. And a translational map, which could be, up 3, left 1, or you'll see something like this, where you'll start with some coordinate, doesn't matter what the point is, and it'll tell you, let's do x plus 3, y minus 1. This is a map that tells you for every coordinate, any x or y, you are moving that point to the right 3 because you are adding 3 to your x, and you're moving down 1 because you're subtracting 1 for your y. This is a translation. There's other types of maps, but in general, this is what you're going to see. It's usually words, sometimes it's symbols and words. Here's a translation. This is where you take a pre-image and just move it. You might hear it be called slide, but the actual name is translation. It's not turning, it's not rotating, nothing's happening, nothing's being flipped. So if you start here with this point, it will end up right here at this point. This point will end up at this point, etc. These will move from here to here. This will move from here to here. And the way you can find your map, how it is moved, is just follow one point and see where it goes. This red dot, this red point, this bottom left corner goes down 1, 2, 3, and to the left 1, 2, 3, 4. Down 3, left 4. This is one place, one way you might be seeing it named. The other map would say for any coordinate x, y, it is being transformed, it is being moved. Left means x is negative, so you'll do x minus 4. And down is another negative, that's down in the y direction, y minus 3. Reflection is to flip something over a line. Whenever you've got a vertical line or a horizontal line, it's really easy to move something. Let's say we've got this triangle, right? What you will do is you'll take this point. You'll see exactly how many steps it takes to go away from this line. In this case, this imaginary example I came up with 5. And you'll do that exactly on the opposite side. So this point would end up here. You'll end up with a shape that is like a mirror image of whatever you just had. Now, the tricky part is when you've got a diagonal line like what we've got right here. What you'll have to do, and there's 2 ways you can do it. I'm going to show you both of them right now. Because it's diagonal, you can still count directly to the line, 1, 2 steps. But because it's not perfectly vertical, you can't keep going 2 in that direction. You're going to have to change directions and go down. You wouldn't want to go up because it wouldn't actually cross the line. You wouldn't go left because you'd end up in the exact same spot. You can't go right because it's not a vertical line, so this way you have to go down. This one here, it's in like the middle of a spot, right? You'll move that little spot, 2, 3 to get to the line, 1, 2, and that little spot to get to the line. Or, here's how I like to do this. If you have the ability to do so, turn the whole thing. So you now have a vertical line. And then it repeats back to the previous pattern, right? You'll be going diagonally through boxes, but you go diagonally through 1, which means to get to your other spot, you go diagonally one more. Right here. Let's see how far away we have to go. 1, 2, 3, 4. Go 1, 2, 3, and 4. Again, this is really helpful to you when you can redraw it or you can rotate it. But realize either one of those ways works. And don't forget, you get graph paper on the SOL, so regraph the whole thing if you have to. Rotation is turning something around a point. So if we're rotating around this point, this distance away, if you're this far away and you turn it, let's say 90 degrees. This isn't a 90-degree rotation, but if it was, if you're rotating it around this point, maybe like the origin, maybe something, it would bring every point right there. This point, you draw a line straight there and turn it. This one's really easy to do. If you take your graph paper, draw your shape, and physically turn what you have. That lets you know what your shape's going to look like, how far you have to turn it, and what coordinates it will turn out to be at. A lot of transformations, if you redraw on your own graph paper, become a lot easier. It's more difficult to manipulate pictures and do stuff on the computer screen. I would recommend redrawing everything. Two different types of symmetry: line symmetry versus point symmetry. Line symmetry, only half of this shape is given, but if we're going to redraw it, and you'll pardon my beautiful drawing, you're going to have a shape that if you draw a line through, it looks exactly the same on both sides. Now, obviously mine doesn't because I did it freehand, but if you had this whole picture of a sun, a line cut straight through it would have an exact mirror image on both sides. This H also has line symmetry, both here and here, because directly above and below is the same, directly to the left and right is the same. But H also has point symmetry. And for point symmetry, you draw a point right in the middle of the shape. And again, if you can redraw stuff, great, because you're going to want to rotate the whole thing. Realize that this H looks exactly the same upside down and right side up. If you can rotate it, either 180 degrees or 90 degrees or any number of degrees, this shape you could rotate a lot and it would end up looking the exact same. But anytime you rotate something less than 360 degrees and it looks exactly the same as when you started, it has point symmetry. Let's try some examples. Triangle ABC. Here's A, B, C. Notice this is A prime, B prime, and C prime. Every time you add a new prime, that means a new transformation has happened. So this is our pre-image, and this is our image. We need to see what has happened from this shape to this shape. And what I like to do is focus one point at a time. Here is point A. Here is point A prime. Here is point B. Here is point B prime. Lastly, C and C prime. Now, it looks like two things could have happened here. It could be just a direct move, a slide, a translation, or some of you might be thinking, well, this looks like it might be a transformation, a flip, a reflection over the y-axis. But it can't be a flip, and here's why. If it were, A is 1, 2, 3, 4, 5, 6, 7 away from the line. If it was a reflection, it would be exactly 1, 2, 3, 4, 5, 6, 7 away on the other side. So because A goes straight from here to here, B goes here to there, C goes here to there. They all make the exact same jump, the same slide, the same move. This is a translation. This says across the y-axis. You could also say to the left 7 units. You could also draw the map where you have x, y. If it's left, that means x is positive, and y remains unchanged, no up or down. Here, it looks like we could have rotated it. We definitely didn't move it because it's not facing the same direction, so it was not a translation. looks like it could be rotation, but again, you have to pay attention to every single point. Here's A, here's A, prime, B, B prime. That was supposed to be a different color. One moment. Let's try that again. Here's B, B prime, C prime, C, D, D prime, E, E prime. And here's what I notice right away. C is right below C prime, or above. D is right above. E is right above. B is right above. And A is right above. That means nothing was turned. If it was turned, B would have rotated around and ended up right where E is. And that's not what happened here. Because everything is directly across from where it ends. You start here, you end here. You start here, you end here. We have a reflection across this line. This is our x-axis. So we need the reflection across the x-axis. If it was rotation, again, these points would end up on this side and vice versa. DE would end up where BC are. We need to check to see if something has point symmetry, line symmetry, or both. Now, if we check this one, definitely has line symmetry straight through the middle. There is exactly the same thing above and below. And you can check, right? So this point, if we were reflecting it, would end up exactly the same distance away. Same thing here. And all of these spots along here would all end up the same. But we have to check to see if it also has point symmetry, which means if we rotate this shape, will it end up looking exactly the same? So our arrow is currently facing right. If we have to turn it 360 degrees before it faces that direction again, it does not have point symmetry. And as you can see, no matter how much we rotate, this is the wrong direction, and now we're back 360. That means we didn't get the same shape in the exact same position. So we do not have point, but we do have line symmetry. Here, I'm going to try rotating this. Notice the corner is cut in the bottom left and the top right. If I rotate it 180 degrees, the corner is cut in the bottom left and the top right. This means we do have point symmetry. But if you try line symmetry, which it looks like this shape has, right? We don't have this cut corner right here, right below it. It would have to be that this point and this point and this point with this point match up. There would have to be a cut corner right below it for there to be line symmetry there. Same thing vertically. If you try and do it like this cut corner would have to have a matching mirror image directly across from it, and it does not. So we do not have line symmetry for this one. And then we've got this goofy looking little arrow, which is facing like this. No matter how you try and rotate it, you're never going to get back to where you started until you do the 360. So you do not have point symmetry. And no matter where you try and draw a line, if you try and draw it here, you don't have the exact same thing above and below. Even if you try and get really clever and do this weird diagonal line, you don't have the same thing on both sides. So this actually has neither symmetry. So line symmetry, point symmetry, and neither. Things that might have both are things that are they're like regular polygons. Like if you had a square, you could rotate that 90 degrees or 180 degrees and it would end up in the exact same spot. You could draw a lot of different lines of symmetry through it and it would end up exactly like itself. A circle has a ton of different symmetries. You can rotate it any number of degrees and it would work. So it would have point symmetry. It would have line symmetry wherever you could draw a line straight through the center. So these kinds of things would have both point and line symmetry. Good luck. Give these next few problems a try.